KCET 2025 aspirants, welcome back to our channel Diksha Karnataka. In today's video, we are going to solve KCET 2022 chemistry paper. So in this video, I'll be solving the first 30 questions, that is from question number 1 to question number 30, and I'll be giving you the concepts behind these questions, how can you solve it easily. So yes, please watch this complete video, take your pen, take your notebook, sit and try solving these questions with me so that you can understand where is your level of preparation right now. Okay, so yes, one more thing here, the question paper PDF will be available in our WhatsApp channel, and the link of the WhatsApp channel will be there in the description section of this video. Okay, so what you have to do is you have to go to the description section, join the WhatsApp channel, download the question paper and start solving. So wherever you have doubt, you can start solving with me like simultaneously, or you can solve your questions and come here and check the solutions. Okay, so yes, now let's get started. So okay, so now the first question. So I'll be telling you the chapter name from where this question have come, and we'll also be discussing how to solve it. Cisplatin, the correct IUPAC name of cisplatin. So this question has come from the chapter Coordination Chemistry. Okay, so coordination chemistry nomenclature. So cisplatin, the formula or the structure you need to know is NH3, NH3, and we have 2 chlorines. Okay, so if you calculate the oxidation state of platinum, here will be +2, right? So you can see this is not there, this is not there, this is not there, because there is only one option with oxidation state as 2. So definitely by seeing this, we can tell that the correct answer for this question is option number B. But again, let us check the nomenclature. So the ligand should be named first, and the ligand should be named in alphabetical order. So here that is why it will come diamine and then dichlorido. Okay, then platinum, and the charge will be in the Roman numbers inside the bracket, so platinum 2. Okay, I hope this is clear. Now coming to question number 2. Again, this question is also from coordination chemistry. Okay, the crystal field splitting energy for COCl64- is 18,000 centimeter inverse. The crystal field splitting energy for COCl2- will be. Now what is the difference you see here? The crystal field splitting means the splitting between the T2G and EG orbitals, right? So here it is a octahedral splitting, okay, and here it is a tetrahedral splitting. So what is the relation between these two? Delta T is equal to 4/9 of delta O. Okay, this relation you need to remember. Okay, so we'll make this formula box, and if you do not know this formula, please note it down. Now let us calculate. We need to calculate delta T, 4/9, and delta O is 18,000, right? So now if you solve this, we will get 8,000 centimeter inverse. Okay, so the correct answer for this question will be option number D. Now coming to the third question here. Again, the question is from coordination compound. The complex hexaamine platinum 4 chloride will give dash number of ions on ionization. So this question is from your Werner's theory. Okay, so if you remember the postulates of Werner's theory, it says that the complex, okay, that will not dissociate in the water, it will remain as it is, and the auxiliary ions will dissociate. Now let us try to write the compound formula for this one. Hexaamine platinum 4 chloride. Okay, so the platinum is there and we have hexaamine. Okay, and the charge of this one is platinum charge is +4, and you see NH3 is a neutral ligand, so definitely this complex charge is also +4, and we have chloride ion Cl-1. So then if you do cross multiplication, I will get this as the formula of the compound, right? Now if you dissolve it in water, okay, so like if you dissolve it in water, what will happen? This complex will get as 1 ion, and the 4 chlorines will be formed as 4 different ions. So now if you see, the total number of ions produced will be 5. So the correct answer for this question will be option number B, that is 5. Now coming to the fourth question here. So we have reached now organic chemistry. In the following pairs of halogen compounds, which compound undergoes faster SN1 reaction? So if you know SN1 reaction order, 3 degree, 2 degree, and then 1 degree, right? The chapter from where this question has been asked is Haloalkanes and haloarenes. Okay, I'm giving you the chapter name. Why? So that you can understand which chapter is very much important. So you can see from coordination chemistry itself we have got 3 questions in 2022, right? So now if you see in this set, okay, this is 3 degree. So I hope this is visible. So in this set, this is 3 degree and this one is 2 degree. And in this set, this is 2 degree and this is 1 degree. So out of these two, this 3 degree will react better, right? And out of these two, the 2 degree one will react better. So from the first set, I'll have this one. So I think this is not there in the option, like in the component, so we can cancel this one. Here they are telling this one will react faster, right? But that is not the case. Why? Because we have a 3 degree. So that is why this option is also wrong. Now the same case, that is, this option is also wrong. Here you see the tertiary will react from the first two, and from the second two, the secondary will react. So the correct answer for this question is option number C. Okay, I hope this is visible. Option number C is the correct answer. Okay, this was again a easy question. Okay, so we'll be writing the level of the question also according to me. I think this question was also damn easy. And this one I will mark as moderate because you need to know this formula, okay? And the first one is also easy if you know the nomenclature, and if you have studied something about cisplatin, then it is a very easy question. Okay, now coming to question number 5, the only lanthanide which is radioactive. So this question is from your DNF block, okay? So the answer for this is your promethium. Again, this question is easy and it is fact based question. Okay, you just need to know this fact. Okay, there's nothing more logical in it. Next, okay, all CO2 halides are known except the iodide. The reason for it is that. Okay, again this question is from your DNF block. Okay, so this is because copper, the iodine, okay, I minus gets oxidized to I2 in place of copper, in the presence of copper. So that is why Cu2 plus oxidizes iodide to iodine, and that is why we do not find CuI2. Okay, so the correct answer for this question is option number C. This is an important PU level question also. In your board exam also this question is asked. Okay, an important reasoning question. Now coming to question number 7. An organic compound with molecular formula C7H8O dissolves in NaOH, okay, and gives a characteristic color with FeCl3. So FeCl3, it gives a characteristic color, means it has the phenol group, okay. On treatment with bromine, it gives a tribromo derivative. Okay, the compound is. So first of all, we know that it has to be phenol because it is showing test with FeCl3, okay. Next question is, it giving you tribromo, and we have the formula one more carbon has to be added, right? So there can be, the carbon can be here, can be here, can be here, and these all positions are there. But now you see, if I treat it with bromine, okay, bromine water if we treat, and we know that this is an orthopara directing group and we are getting a tribromo derivative. So what should be the product? This has to be the product, right? That means that methyl group cannot be, so I'll highlight this. So the methyl group cannot be attached at these positions, because at these positions we will get bromo group, because it is said that on treatment with bromine we are getting a tribromo derivative. So if these positions are occupied methyl group, then we will not get a tribromo derivative, right? I hope this concept you are getting it. So now if this is there, then where we can add the methyl group? We can add the methyl group in this position, right? So the methyl group must be here, that is M in the meta position. So this is called as metacresol group. Okay, so the correct answer for this question is option number D. So I'll tell this question was little moderate. Okay, the reasons for that is common names are given. Okay, and we most probably know about the IUPAC name and we do not give importance to common names. So you can see the options here, and they are all are your common names, right? So that is why you need to be little careful. Now coming to question number 8. In Cole's reaction, the reacting substance are. So if you remember, this is a name reaction. In cold reactions, we take phenol, okay, and then you take sodium, we get ONA, right, and then you treat it with CO2, and we get, and then we hydrolyze it, we get OH and we get COOH. So the reactants are sodium phenate, this is sodium phenate, and carbon dioxide, right? So the correct answer for this question is option number B. Again, this question is easy because it is a direct name reaction question from the chapter Phenols. Now coming to question number 9. The major product obtained when ethanol is heated with excess of concentrated sulfuric acid at 443 Kelvin. So we have ethanol. So if I draw the structure of ethanol, so I'll use little color scheme here so that you can understand. Okay, and if you heat it with concentrated H2SO4 at 443 Kelvin, then what will happen? This part will be dehydrated, right? So if this part gets dehydrated, then the product formed will be CH2 double bond CH2, right? So correct answer will be ethene. Sorry, option number B. Okay, so this is also again a very easy question, reaction based but easy and simple reaction. Now question number 10. Among the following products formed by the reaction of anisole with HI. Again, anisole structure you need to be known. Common name is given. So anisole is OCH3, right? This concept is from ethers. Okay, very important, cleavage of ethers, and Wood's reactions are very, very important. Now if you treat it with HI, the phenol will take always OH. Okay, this bond cannot break. So here there will be OH and we will get CH3I, iodomethane. So phenol plus iodomethane. Correct answer is option number B. Okay, I hope everybody would be agreeing with this. Whenever this phenol group is there, O will always be attached to phenol. There is no way that this bond can be break because we know this has a partial double bond character. Okay. Now coming to question number 11. Which one of the following cyclohydrocarbons readily undergo solvolysis? So for this you should know, if we are getting a stable carbocation, okay, then that will undergo hydrolysis or solvolysis easily. So now let us try to form this carbocation in all the options. If this chlorine goes out, this is the carbocation forming here. Here this carbocation will form, here this carbocation will form, and here this carbocation will form. Now if you see, these two carbocations are very unstable because they are on sp2 carbon. Now if you see this one, this carbocation is stable due to inductive effect, but if you see this one, this is a benzyl carbocation and is very, very stable due to the resonance effect, right? So that is why solvolysis will be faster in this one, option number D. So the correct answer for this question is option number D. Now coming to question number 12. Identify the following products A and B in the reaction. So here the game is of reagent. If you use CN, then we get RNC, and if you get KCN, we'll get RCN, right? So here NC, this is wrong. CN, this is wrong. CN, again this is wrong. We have RNC and RCN. So correct answer for this question is option number D. Okay. So this was, I think, from haloalkanes chapter. This reaction is there. Okay, and again I'll mark this as an easy question, students, because direct reactions are there, nothing any confusing or any twist and turn question. This is not like that. Okay, now coming to question number 13. Which of the following reaction by which benzaldehyde cannot be prepared? Okay, so if you treat benzoyl chloride with hydrogen, yes, we can prepare. I think this is the Rosenbaum reaction. When benzene with CO&HCl, this will also give you. Benzoic acid, if you treat with zinc and mercury, okay, that will not reduce it to benzaldehyde. Okay, you can, with zinc and mercury you can reduce aldehydes and ketones but not acids. So that is why this will be the correct answer, or by using this method we cannot synthesize benzaldehyde. Okay, so correct answer will be option number C. Next, coming to question number 14, the test to differentiate between pentane 2-ONE and pentane 3-ONE. So if you see pentane 2-ONE, we have this structure, pentane 2-ONE, and then we have pentane 3-ONE. Okay, so now if you see for showing this pentane differentiating, you can see that this group is having this acyl group, right? CH3CO group, if it is present, then it will show positive iodoform test, and we can get a yellow precipitate here. So the correct answer for this question will be option number A, iodoform test. Okay, this one will not show because it is not having this CH3CO group. Okay, now let us see the next question. In carbyl amine test for primary amines, the resulting foul smelling product is. So carbyl amine test, again this question is very direct one from your amines chapter. So the foul smelling smell is due to the presence of isocyanide. Okay, question option number D. Okay, I think all of you have known this reaction. So we will get a foul smell because of the production of isocyanides. Now coming to question number 16, ethanoic acid undergoes HBZ reaction but methanoic acid does not. This is because of. So in HBZ reaction what happens? Suppose you have CH3, COOH, and in HBZ reaction what happens? The alpha hydrogens get replaced with a halogen, right? So it happens like this. We have this one, right? Now what happens here? This happens because there is a presence of alpha hydrogen. If I take methanoic acid, okay, then this is not alpha hydrogen, right? So this reaction cannot take place in methanoic acid. So the correct answer for this will be presence of alpha hydrogen in ethanoic acid. That is option number C. Okay. Now coming to question number 17, the general name of the compound formed by the reaction between aldehyde and alcohol. So if you have an aldehyde, suppose RCOH, and we have an alcohol R-OH, okay, then this one will react here, this one will go here. So what it will form? RCO minus, then we have H, and then we have OR. Okay, then again if you treat it another molecule of alcohol, then we'll get RCOR, OR and H, right? So now this type of compounds is called as acetal and this compound is called as hemiacetal, right? So the correct answer for this question will be option number C. Okay, now coming to question number 18. Which institute has approved the emergency use of 2-deoxy-D-glucose as additive therapy for COVID-19 patients? The exam was in 2022, so at that time, as you all know, pandemic was very just a recent incident, so such questions were asked, some general knowledge question here. The answer for this question will be Indian Council of Medical Research. Okay. Now coming to question number 19. A nucleic acid, whether DNA or RNA, gives a complete hydrolysis, 2 purine bases, 2 pyrimidine bases, a pentose sugar and a phosphoric acid. Now nucleotides which are immediate products in the hydrolysis contain. So what are the products of a nucleotide? So you know that a nucleic acid, see the hierarchy is like this. Nucleic acid is made up of nucleotides. Okay, nucleotides are made up of nucleosides plus phosphate group, right? And nucleosides are made up of bases and sugar. So here the bases can be of two types, purines and pyridines, right? Now if you see, if a nucleotide is hydrolyzed, what will get? Purine or pyrimidine base, a pentose sugar and a orthophosphoric acid. So the correct answer for this question will be option number A, a very easy and direct question from the chapter Biomolecules. Okay. Next question, question number 20. A secondary amine is, this is somewhere like people very often get confused because secondary we have alcohol, secondary secondary haloalkanes. With that, this definition is little different. So secondary amines means in ammonia we have 3 hydrogens, right? So if you replace one hydrogen with an alkyl group, we call it primary amines. If you replace 2 hydrogens with amines with alkyl groups, we called it secondary amines. And if you replace all the 3 hydrogens with the alkyl groups, then we call it tertiary alkynes, tertiary amines, right? So that is why secondary amine, a compound in which the 2 of the hydrogens of NH3 have been replaced by the organic groups. So correct answer is option number A. Again, this is a super easy question, but a very, very fundamental and basic question. Okay, now let us move towards next question, that is 21. Which of the following is correctly matched? So this question has come from the chapter Polymers, okay, which is now deleted for you. So you need not study this chapter at all, okay, but I'll be telling you the answer also. So the correctly match is bakelite and novolac. Okay, so this is the polymer, this is the monomer. Okay, now let us go to the next question. 2022. Sorry, question number 22. Elements X, Y, Z have atomic numbers 19, 37 and 55. So 19, 37 and 55. So what do you find them? Can you find any difference or any numbers between them? So if I think if we add 18 we'll get here, right? Then again if you add 18 we'll get here, right? So now you know where do we add 18, 18, 18? When we move towards a group, right? First we add 2, 8, 8, 18, 18, then 32. So what does that mean? That these three elements 19, 37 and 55 belongs to one group. Okay. Now can you tell the can you just identify the element's name? Potassium is 19, right? So lithium, sodium, potassium, then we have rubidium and we have cesium, right? Lithium, sodium, potassium, rubidium, cesium. Okay. Now let us read the statement. So this is my X, this is Y and this is Z. According to the question we don't know the names, but we only found out that they three belong to one group. That is what you need to find out. Y would have the highest ionization potential. Is it correct? Ionization potential down the group decreases, right? So this statement is incorrect. Their ionization potential would increase with the increase in atomic number. Is it correct? Again no, the atomic number is increasing, but we know down the group ionization potential will decrease. So this statement is also incorrect. Now, Y would have an ionization potential between those of X and Z. Yes, this is correct. Why? The potential ionization potential order will be in this way, right? So Y will come between X and Z. So this statement is correct. So your correct answer for this question is option number C. Okay, now let us see the last option. Z would have the highest ionization potential. This is wrong because Z will have the lowest ionization potential, as down the group ionization enthalpy decreases. Okay, so the correct answer for this question is option number C. Okay, next question. In oxygen and carbon molecule the bonding is, so oxygen we know like this and carbide molecules occur in like this. So in oxygen we have 1 sigma 1 pi, carbon 1 sigma 2 pi. So the correct answer for this question is option number D. This question was from your chemical bonding. Okay, very, I'll say little moderate question. Okay, because Lewis structures and all is not very easy to draw if you have not understood properly. So on the moderate side. Now, which is most viscous? Okay, so this is also a very easy question if you know glycerol. Okay, glycerol has more number of OH, right? So if more number of OH, what will happen? There will be more hydrogen bonding. If more hydrogen bonding, then the molecule's viscosity will increase. So the correct answer for this question will be option number A. So this question was from alcohols. Again, I'll mark them as easy question, but again little tricky one, not direct question, but you need to little apply the concept of intermolecular hydrogen bonding. Okay. Now coming to 25th question, the volume of 2.8 gram of CO at 27 degrees Celsius and 0.8 to 1 atmospheric pressure is. Okay, so this question is from your ideal gas equation. Okay, we have the formula PV is equal to nRT, right? So now if we calculate, what we need to calculate? Volume. Volume will be nRT by P. Now N, let us calculate number of moles. So 2.8 by 28, okay, given mass by molar mass. R value is given to you 0.082, okay, and temperature is 27, so it is 300, okay, and then we have pressure. Pressure is 0.821. Okay, so you can see how the numbers are given so that it can be easily cancelled. So if you solve this, you will be getting around 3 liters. Okay, so correct answer for this question is option number D. Again, a very easy question. Okay. Now coming to question number 26, the work done when, so work done question means from thermodynamics, right? Okay, so the work done when 2 moles of an ideal gas expands reversibly and isothermally from a volume of 1 liter to 10 liter at 300 Kelvin. Okay, so we need to calculate here work done formula. work done is minus 2.303 into nRT. So 2 R value is again 0.0083 and T value is 300 Kelvin. Okay, log of, we have V2 by V1. So log V2 by log V2 is 10 by 1, log 10 is 1. So I am having minus 2.303 into 2 into 0.0083 into 300. Okay, so now you can solve this, and if you solve this, you will be getting around 11.5 kilojoule. The correct answer for this question will be option number B. Okay. Now let us see the next question. So again, this question is a easy and direct question. Okay, direct formula based question. No need to use any complex concepts, nothing. Direct formula based question. Now coming to 27. An aqueous solution of alcohol contains 18 gram of water and 414 gram of ethyl alcohol. The mole fraction of water is. So this concept is again from your concentration terms, right? So this is there in your first chapter and also in the solutions chapter. Now let us see ethyl alcohol, CH3, CH2, OH. If I add the molar masses, so 12, we have C2, H6 and O, right? So 24 plus 6 plus 16. So 24 plus 6, 30 plus 6, so 46 gram per mole, right? So let me first calculate the number of moles of water. So given mass is 18, molar mass is 18, number of moles of water is 1, right? Given mass by molar mass. And number of moles of ethanol is 414 by, I need to make 46, right? Then we can cancel it. Okay, so I'll get around 23. Okay, next can we cancel it? Yeah, 9. 23, 9 3s are 27, 9 2s are 18, 19, 20. So 9 moles. Now the question is the mole fraction of water. So for mole fraction of water, I need the number of moles of water divided by the number of moles of water plus the number of moles of ethanol. Right? So that will be number of moles of water is 1. 1 divided by 1 plus 9. So 1 by 10, that is 0.1. So the correct answer for this question will be option number B. Again, I will mark this question as very easy and formula based and direct question. Now coming to question number 28 here. If the wavelength of a photon is, so this is from your structure of atom, right? Okay. If the wavelength of the photon is 2.2 into 10 to the power of minus 11 meter and h is 6.6 into 10 to the power of minus 34 joule second, then momentum of the photon is. So we know this formula, de Broglie's wavelength, lambda is equal to h by p. So momentum will be h by lambda. Okay, so let us substitute the values here. 6.6 into 10 to the power of minus 34 joules seconds. Okay, divided by lambda is 2.2 into 10 to the power of minus 11, right? So this one will become 3. Okay, so 3 into 10 to the power of 23, minus 23. So the correct answer for this question will be option number B. Again, this question is easy and direct question. Now coming to question number 29. In which of the following compounds an element exists two different oxidation states? So here if you see, nitrogen has a single oxidation state. Here nitrogen also has a single oxidation state. If you check this one, this is a salt, right? It is in this form, NH4 plus and NO3 minus, right? So if you calculate the oxidation state of nitrogen here, okay, that is minus 3. But if you calculate here, it will be plus 5. Okay, so in the same compound, two different oxidation states are exhibited. So the correct answer for this question is option number C. So this question is little moderate. We need to identify properly. Okay. Next question number 30. Which of the following hydrides is electron deficient? So all of you know B2H6 is a Lewis acid. Okay, and it is electron deficient. So the correct answer for this question is option number A. Okay. So yes, students, this was the part 1 of KCET 2022 previous year questions. So if you have any doubt in any question, please comment down. I'll definitely address it. And please wait for the next part of this video where we are going to solve the next 30 questions of KCET 2022, that is from question number 31 to question number 60. Okay, so yes, you try solving these questions and put your scores out of 30 in the comment box. Okay, and all the very best for your KCET 2025 examination. Start your preparation from now, and thank you for watching and subscribe the channel for more such videos. Okay.